Hello and welcome to using the distributive property with decimals. We're going to use the distributive property to help us release the parentheses, in other words, simplify the expression. And I'm going to ask you to show your work. So we're going to start with this expression, 4/10 times the quantity of 1 and 6/10 x plus 3. So using the distributive property, we choose to use those arrows, which I sometimes refer to as rainbows. And recall that this 4/10 it multiplies everything in the parentheses. So if I took 4/10 times 1 and 6/10 x, what would the answer be? The answer would be 0 and 64 hundredths x, or 0.64 x. Then we have to go back and take 0 and 4/10 times positive 3. So I'm going to write what I'm doing so I can backtrack and see if I make a calculation error. I'll know where to look. So what would it be if I had 0 and 4/10 times 3? If you said 1 and 2/10 or 1.2, you're correct. But since we have to write this as an expression, I'm going to take my positive 1.2 and add it. So this is the final answer. We cannot combine these terms because this has an x and this does not. So 64 hundredths is called a coefficient and 1 and 2/10 is called a constant. So now let's go and try the next one. So we're going to write 2 and 3/10 times 6n. And now this time I have to ask myself, what kind of 1.5 do I want to use based on the minus? If you said negative, you're correct. So I'm going to go back to my 2 and 3/10 times, this time negative 1 and 5/10 or 1.5. So pause and use your calculator and then write down the answer. So what would the answer be? And the answer here is 13 and 8/10 n. So let's look at that for a minute. If this wasn't a decimal, let's just say what if. If this 0.3 was not there, this is just pretend, 2 times 6 would be 12. And you notice that this 13 and 8/10 is bigger than 12, but not by that much. And so this 0.3 would add on another 1 and 8/10. So this is a reasonable answer. And sometimes if I'm not sure when I'm using decimals, it's helpful to kind of estimate the answer. So now if you work on the other term, it is negative 3 and 45 hundredths. So I'm going to write that negative as, let's go back to my pen, minus 3 and 45 hundredths, or 3.45. And we could also write this, if you prefer, whoopsies, put no decimal in the wrong place, like this. If you prefer, these mean the same thing, we just prefer using one sign instead of plus and negative. This would be the high school way to write this. Okay, let's keep on going. Let's go into 3 next. All right, for number 3, if I, draw an arrow from 0 and 7/10 to 4.5x, can you tell me what that means I'm supposed to do? If you said that means that I'm multiplying 7/10 times 4.5 or 4 and 5/10 x, you are correct. So next, what happens if I draw an arrow from 7/10 to 0 and 3/10? What does that mean? If you said that means 7/10 times 3/10, you are correct. And the good news, this is positive, so I don't have to really worry about my signs. Everything will be positive. So what is the final answer? All right, 3 and 15 hundredths x plus 0 and 21 hundredths. or if you'd rather pronounce it, 3.15x plus 0.21. Now, let's just check this out real briefly. You're going to notice that this number here is bigger than our answer. And that's because when we multiply a decimal that's smaller than 1, less than 1, it means that the answer is going to also be less than the number that we're multiplying it by. So now let's move on to number 4. And this is going to be a little bit tricky because we have a negative out in front, and then we also have a minus sign. So we have to be super careful about our signs. So we're going to start the same process we always use, and this means negative 3.6 times 2.5a. So side by side means multiply. Now this is the difficult one because I have to go back, and I sometimes don't recognize this number is also being multiplied, but I take this negative 3.6 and now I have to really pay attention to this sign. It's negative 1.9b. So if you've worked with these faces before, I have a negative 3.6 and I have a positive 2.5. And so this is going to yield a negative number. So pause and use your calculator and tell me what the answer is. If you said 9a, you're correct, and that might have been a surprising answer. As we look at the next two factors, I have a negative 3.6 and a negative 1.9, and that would yield a positive answer. So the story goes, if she's all the way all the way asleep, she's happy. And if she's half asleep, she's mad. So please tell me, when you multiply these two factors, what the answer is. And if you said it was 6.84, you're correct. So 6.84. And we have to remember those negative times a negative is going to give me a positive. So briefly, I want to acknowledge there's another way to do this. So the first term, no matter which way we did it, would still be negative 9a. Now, sometimes we're taught to just drop down this sign. So if I drop that down as a minus, then that would make this 1.9 into a positive 1.9, and then I'd have a negative times a positive, which would be a negative. So that would yield negative 6.84, and I just discovered I forgot the b on that, so that's my fault. If you look at the two, this is much less complex. I just have one sign. And if I looked at the second expression, these double signs are very tricky sometimes. In fact, we would choose to do our keep, change strategy, which would mean we keep negative 9a. We'd change that minus to a plus, and we'd change this negative 6.84b to its opposite, which would we'd be right back to where we started in the first place. So using your minus sign sometimes as a negative sign is much easier than just dropping down the sign, because when we do that, we sometimes get into this double sign land, and that can be tricky. Thanks for watching. Have a great day.